Hello everyone, welcome to you all to the YouTube channel of Developers and Coders Club of NIT-A. Today we are going to discuss the problem element decompress from the latest Codeforces round 842 of Division 2. So let's read the problem statement first. So in this problem we have given a array which consists of n integers. We have to find two permutations p and q of length n such that the max of pi and qi equals to ai for all I belongs to 1 to n, and report if p and q do not exist, right? A permutation of length n uh, is an array consisting n distinct integers from 1 to n in an arbitrary order. For example, uh, just like 2 3 4 and 5. So it is the permutation of n equals to 5 because from 1 to 5 every integer is present in this and no repetition, right? And is a permutation, but 1 to 2 is not a permutation because it's having three integers, but 2 appears twice. So this is not a permutation, and this is also not a permutation because all the integers from 1 to n should be present in this. So here 2 is missing. So I think permutation should be clear to you all what is the permutation. So let's understand the problem first. And in the output we have to return yes if p and q exist, and if not then we have to return no. So let's understand the problem first. So here I uh, have an example where n equals to 5, n equals to 5, and the 5 integers are like that. We have to find 2 p and q, two integers p and q such that the ith means here I have written p1 p2, and so the maximum of these two equals to 5 for the first, and the maximum of these two equals to 3 because the condition is like ai, this is ai, so this is ai should equals to max of pi and qi, right? So I have to find two independent p and q permutations from 1 to 5, uh, which having the max of the ith index equals to ai, right? So let's uh, understand. I hope you all understand what is the problem asking. So let's move to the solution approach. So what do you think? Here two integers 5 and 5 appear twice, right? 5 and 5 appear twice. So if any integer, let's assume for the first we have to we have to think when this should be giving no to me, right? So let's assume if we having two integers, if we having 5 appears thrice in this. Let's imagine if I if 5 appears thrice, like 3 is not present here. I imagine 4 2 5. So yeah, so uh, think 5 appear thrice. So we having only two permutation p1 and q1, and we know 5 appears only twice in this. 5 is the maximum value and 5 appears only twice in both the permutations from 1 to n. So if any number appears more than twice, more than 2 times, then we have to return no in this case, right? Because there are only two permutations. So for the existence of any number, for any ai, there should be only two possibilities that uh, of having ai occurs twice, because there are only two permutations p1 and q1. So if any number appears thrice, then we can say this is not possible. So we just return no in this. This is the basic first condition for printing no, right? So let's move towards the answer of this, when we have to return yes, and how we formulate these two. It is a constructive type of problem, so uh, we have to just think about it, right? So how can we approach? Here we having, let's uh, write them now. More 3 4 5 3 4 2 and 5. So uh, in a permutation of in a permutation of n numbers, the actual permutation, right? I have writing a gen normal permutation for this. So what is this? What will be 1 2 3 4 and 5, right? It is a general permutation. So yeah, so think, in this AI we having the missing number. One number is missing. What is this? This is 1, right? And all the numbers are occurring, and 5 occurring twice. That's why a number is missing. So for occurrence of any number twice, we having missed out a number in a permutation, right? We having missing out a permutation number, because if a number occurs twice in the array, then a number is, it's absolutely missed a number in the actual permutation, right? So this number is, so first I run a loop from 1 to, means I first I store all the numbers which are missing in this, right? So in this example, the only missing number is 1. So I store 1, right? I store 1 in an array. And now moving forward, I know, uh, moving forward, I know that those numbers which occurs only once, like 2 4 3. So that if I taking max of these, if we have to formulate p and q, right? So imagine, here the numbers which appears only once are 3 4 2. So if I write 3 4 2 in p in this order, and similarly, I wrote 3 4 2 in q also. So the max of these two is 3, the max of these two is 4, and the max of these two equals to 2. So those numbers which occur only once, we don't do more for that. We only just uh, uh, store them in p and q in the same order which they are occurring in the actual array, right? Because the max of these two will also give me same number. And we know that the numbers which occurring twice, if a number occurring twice, then is can take a position, is take a number, it's means it's like in this, like 5 occurs twice, so one is disabled, one is not present in the actual array. So for every number which occurs twice, it's replace a actual number of a permutation. So I know, if a number occurs twice, then is absolutely take a number from the actual permutation. So I store them, right? And for the numbers which occurring only once, I just copy them on the same indices as they are, right? So here are two positions left with this first and the last, first and 1 and n for both. So we have to, like in this 5 and 5. So if 5 and 5, so and I have left with one student. So if I know, if I take 5 here, if I write 5 here, so what the number which is not present in the actual array is 1. So I know I can replace it with 1, the q's part of the same index with 1. And I know that the nth position of this number is, so here I uh, found that 5 is present in this and this place. So I have to just twist the lower and upper part in the both the indices. So here I write 5 1, So here I just write 1 and 5. So let's check. All the numbers, all the numbers are present in the are in permutation from 1 to 5, and in the lower also this is in a permutation, and check for the condition which are in the question. So max of these two equals to 5, max of these two equals to 3, max of these two equals to 4, max of these two equals to 2, and max of these two equals to 5. So this condition holds. So in this I just written yes and these two, yes and these two. uh, so yeah, from this approach, there is I just use the what I used what asked in the question. I don't do much more in this. I just store all the remaining elements. Means I store the all the remaining elements which are not present in the actual array from the permutation of 1 to n, and I store in these. And I know that if a number occurs twice, then some of the numbers are not present in the actual array, right? Because it can take the position of take the value position of that element. So that's why I store them in a vacant array, and I just copy all the elements which occurs once to the same position in both the p and q, and just for a given value I know 5 occurs twice, so I just store these two indices and replace the values accordingly. Means I here I write 5 1, and in this I just write 1 and 5. So uh, let's check is this work for everyone, every case. So right, let's take another example. So here I just write I having n equals to check means n equals to 4, and here I write 3 3 3 3 and 4 4, right? This is the actual array. We have to find p and q accordingly. We have to find p and q. So according to my approach, what can I do? First I take the those elements which are not present in the actual array, and which are the part of permutation from 1 to n. So I store them. So 1 is not present here, and 2 is also not present, right? So here I what I do, I just uh, here 3 and so no number is occurs only once, so I can't uh, write the same number on both the P and Q. So here for one, let's check. So 1 and 2, and I know the indices of 3 and 3, these two indices. So for that I just replace, here I write 1, and so to make this 3, what can I what I have to write here 3, and I know the another index of 3 is also here. So in this I just reverse this. I write 3 and 1, and for 2 I know this is, if I write 2 here, then this is should be 4, and I just reverse the 2 4 2 4 2 in the another index or presence of 4, right? So yeah, mm, in this case this is also should also be valid. So let's check another case. If for the same example, if I having 2 2 and let's 2 2 and 3 3, let's imagine if we having 2 2 and 3 3, if we having 2 2 and 3 3. So the remaining what the numbers left from the permutation are 1 and 4. 1 and 4. So I have to return P and Q accordingly. So if I'm trying to here, I have 2 or 2. So if I trying to 1 here, then I have to write 2 here. And when I am trying to, I just reverse this because I know the indices of both 2, and here 3. So if I am going to write 4 here, I have to return 3 here. And if I am going to write 3 here, I have to write 4 here because it's reverse. But check uh, when I'm um, when I'm trying to take the max of these two, right? When I'm trying to take the max of these two, if I'm reversing reverse this to find array A, then this should be 1, this should be, no, this should be 2 and this should be 2, fine, but this should be 4 and this should be 4. So from here I find that we can't do this in we can't do this operation in this case. So in this we have to return no, right? So here the after formulating this, according to my approach, after formulating this, we finally we have to check is the a- array AI is same as the array we have formed from P and Q. Is the max of these two equals to the actual array? If not, then we have definitely written no. So the uh, basic idea is like that. We know the if a number occurs twice, then it's can take a number of from the permutation. So we just store these numbers here and just reversing the indices means if I write 1 and 3, I know the here 1 in the max value is 3, so I have to write 3 and one lower value, and then same goes for that reverse. So I hope you got the problem idea how to formulate BQ. To understand it more, let's move on to the code where I show you how I write the code for that. So yeah, so for this I write the code. Here I take two integers, one integer n, which stores the number of elements in this, and I take an array of n, which stores the mm, actual array. And here this is you can also not take, you can also skip this. This is not because in the question is n should AI should always be less than n. So I don't much aware in the context about this. That's why I write here. So let's magnify this. Yeah. So you can skip this also. I create a test equals to 0 if I just increment the map uh, of every value in map. If any value is greater than 2 in map, then then the test becomes 1. And if I found that test equals to 1, then I have to simply return no, because I know a number can't appear twice, because if it occur more than twice, then definitely we can't construct the array. Yeah. So and I as I told you, I check from 1 to n, and if any number is not present in a map, I just take this in a vector which store all the numbers which are not present in the actual array, right? And we have to construct p and q. So I create a vector of length n and q a vector of length n, and then finally I just run a loop, which if any number having only one occurrence, then I just copy the number to the p and q, because I know the max of these two is also one, and these numbers can't affect the whole array, right? And finally to I take a pair which stores which stores the value and the index of the number, because I know the values which occurs twice having two occurrence means it's occurred twice in the array. So that's why I take the value and its index in pair. And finally I just sort, because I know that the occurrence of a number is I stored in the pair of vector those numbers which occur twice. So after sorting those all numbers comes there means all the numbers are continuous, means 5 occur twice, so 5 uh, present in 5 in the continuous position, right? And finally I store uh, the size of these vectors, and the vector v which I store the number which are not present in the array, right? Because x and y both the now we copy the p and q in the actual position of which occurs only once. So these numbers can't affect this. So the dependence of these two numbers which are not present and which present twice only depends now to each other. So for that I just check it's not mandatory because this is obvious that it should be uh, present twice as the numbers present not present in the array, right? So you can also skip this, but yeah, here I just check that the vector size should be equals to not the numbers not present in the array sh- uh, uh, is twice as the number of vectors, number of uh, elements which present twice in the array, right? So you can also skip this because it should be obvious if the condition hold. So right, so now I run a loop from the max value because I have just in the first I have to just uh, in the first I have to just reverse taking the maximum values from the those values which occurs twice. So I take the maximum values, I run a loop from the from the back because I sort the array first. What's going? Yeah, and I run a loop for those number which are not present in the array, and this is also from back because uh, we know that in some cases if I take from starting, then it may be possibility that the numbers which are not present in the array this should be greater because if I take this from back and this from means we have to start from any position, but if I start this from starting then I should be start from this from the start, and if I start this from back definitely I have to start this from back because we are taking the max of these p and q. So here p in the vector of pair I store second as the index. I store the index of the value index. So in pq the index should be the actual value which occurs twice, and in the q's same index we store the number which not present in the array, right? And for the same because the numbers are present in the pair, so that's why I am decrementing this from two times to decrement every time I decrement by 2. So that's why I am using I and I minus 1 because both the numbers are present in the pair, so that's why I'm doing this. So in the pth second index I store this the same value means the same. Here I am using the reversing part which I understand which I told you in the uh, logic that I just reverse this. Here I storing p vi index as first value, and here I am storing the number which is missing. So yeah, this is the but just reversing part. You can understand it well in the solution part, right? And in the finally I told you uh, uh, I told you a example where the we can construct p and q but we can't find that both the max of pi and qi is same as the ai, so that's why I'm checking this final condition for checking it is possible that it may be possible that the both we can construct p and q but not in the manner which required in the question. So that's why I'm checking this. If I don't find any of the max of these two not equals to a, then I have to return no, and if I found then I have to just return yes and return both the permutations, right? I hope it is quite clumsy, but I hope the problem should be clear to you all. You So thank you.